Welcome everybody to day 15, another great day to learn and master Kubernetes. Do not underestimate the little progress that is made every day. Yesterday we began a deep dive into deployments, but even then the time was not enough for me to cover everything. So let's continue with learning today. I will scroll up to the point where we stopped. Of course, we studied so many things, okay? We looked at deployments, okay? More details concerning deployments, okay? We looked at one way of changing, okay, an image. We looked at what else? How to roll out, okay? I mean, how to edit, okay, a deployment. It was either using the set image command or using edit, okay? So we looked at rolling out status and so many details, okay, that I can't simply summarize in a minute. So if you missed that, watch the previous video. So today we're going to continue from this other section. Where is it? Should be down here. Was it selector? I think, yeah, this is it, okay? Rolling back a deployment. Okay, later on, I'm even going to take time to read this thing as many times as I can. Okay, so I suggest that everybody who is learning Kubernetes with me, read this as many times as you need. Okay, and particularly for me, I'm going to go back and read these documentations again. So rolling back a deployment, they're saying sometimes you may want to roll back a deployment. For example, when the deployment is not stable, such as crash looping. By default, all the deployments rollout history is kept in the system so that you can roll back anytime you want. You can change that by modifying revision history limit. Okay. All right. I hope that makes sense to you. Okay. So yeah, sometimes you may want to you may want to roll back a deployment, for example, when the deployment is not stable, such as a crash looping. And they're saying by default, all of the deployments rollout history is kept in the system so that you can roll back anytime you want that change by modifying revision history limit. Then we'll go back to the note. They're saying a deployment revision is created when a deployment rollout is triggered. Okay. Remember, we studied what causes a deployment to be triggered. Okay. It is when everything in the selector, spec.selector is edited. Okay. Like if you change the container image, okay, that can affect, I mean, that can cause a trigger. Okay. Do not forget that. And of course, like I've told you, read this again and again. So I'll continue. They're saying this means, okay, this means that the new revision is created if and only if the deployment pods template, okay, is changed. Remember I told you, we have just said a minute ago, that a deployment rollout is only triggered when .spec.template is changed. Okay, don't forget the small basics. Let's read this again. They are emphasizing the point, which is very good. They're saying this means that the new revision is created if and only if the deployment's pod template.spec is changed. For example, if you update the labels or container images of the template, okay, if you update the labels or container images of the template, okay, so the .spec.template, okay, has labels, okay, and images, okay. Let me take you to this so that to remind you, okay. So you see .spec.template, okay. What does it have? It has the labels, okay, has the labels and has the images, okay. So if we change the label, okay, or change the image, that is when a new rollout is triggered. Okay, very important. Now we go on to read the saying other updates such as scaling the deployment do not create a deployment revision. Okay, so that you can facilitate simultaneous manual or auto scaling. Okay, so scaling does not create a revision. Very important. What creates a revision? When you update the .spec.template. What does it mean to update the .spec.template? It means you're either changing the label or the image. Simple. Okay. This means that when you roll back to an earlier version, I mean to another revision, not version, but revision. This means that when you roll back to an earlier revision, only the deployment's pod template part is rolled back. When you roll back to an earlier revision, only the deployment's pod template part is rolled back. Okay, so this part, okay, this part of the template, only it is what? The pod template part, okay, the part that affects the pod, okay, is rolled back. Okay, everything else remains. Okay, but remember this number of revisions back in time, okay, have a limit. Okay, they say you can modify the revision history limit. That is something good to know. Okay, let's go on. So they're saying, suppose that you made a typo while updating the deployment by putting the image name as Nginx 1.161 instead of Nginx 1.16.1. Okay, so you see that here there's a point, a period before the one. Here there's no period before the one. So that's a mistake. Okay. So that's a mistake. All right, let's continue. So you're seeing here, you're saying kubectl set image. Okay. Set image to deployment. This is the deployment. Okay. Nginx deployment. And they're saying the container is called Nginx and the new image is this. Okay. But you see, I've set it using the mistake. Okay. And now they say the output is similar to this. Image, okay, updated. Now they're saying the rollout gets stuck. You can verify it by checking the rollout status. Okay. Now we have done these commands again and again. Okay. Ensure you also practice them again and again. So I'll copy this command and get back here. I don't know if our Minikube was still running. They stop it. Let me see. I think I had stopped it. All clear and say Minikube start. We need to have it working immediately. Okay, taking some time. Preparing Kubernetes. Verifying Kubernetes. Using the image. Okay, so yeah, looks like it's now good. So I can come in this other terminal. Okay, close this, clear. Okay, change the image. Okay, so we have edited. Remember, this is one way of editing a deployment. Then after that, you see we have the message. Okay, image updated. Okay, Nginx deployment updated. Come on, what have I just done? Okay, then if we check out the rollout status, okay, kubectl rollout status, then the deployment name, okay. So it says waiting for deployment, Nginx deployment to roll out to finish. 1 out of 3 replicas. They're saying waiting for deployment, Nginx deployment rollout to finish. 1 out of 3 new replicas have been updated. So when I go down, you see they say the output is similar to this, and that's exactly what we have. Okay. They're saying press Ctrl C to stop the above rollout status watch. For more information, check out. For more information on stack rollouts, read more here. Okay, we won't go there for now. Let's build on. So they're saying you see that the number of old replicas, okay, they're saying adding the replica count from Nginx deployment, okay? And Nginx deployment is 3, okay? So it's in the number of all replicas, okay? Adding the replica count from this one, okay? And this one here is 3. And the count of new replicas from this one is 1, okay? So we can see the number of replicas by using this command, okay? But let me first do a Ctrl C, clear. Say kubectl get replicas, okay? So you see that the old one, of course, our hashes may not combine, may not match, but okay, but the concept is exactly the same. So from the old replica, okay, see this, okay, this one here, this one we created yesterday, okay, this one has nothing, okay, 000. But there's this one here that we had yesterday, okay, has 3, okay, 3. The new one has 1, okay. Do you see that? Okay, that's why they say like this. You see the numbers from old replicas, okay, is 3, okay. This is the old one having 3, okay, that we desired 3 replicas and 3 were given to us and 3 are ready, okay. Then from the new number of the new replicas is 1. If I go back here to the new one, we have only 1 that is desired and 1 is current, but it's not ready, okay. Take note of that, okay. So the same output is similar to this, okay. Yeah, that's what we got. They're saying, looking at the pods created, you see that one pod created by new replica set is stuck in an image pull loop, okay. We can also do that. kubectl get pods, okay. Are you seeing this one, image pull back off? And are you seeing how it is? It's saying 0. The first one is for desired, the next one is for current. So the current state says 1, but this one is for current, this one is for desired state, okay. So the current state is 0, it's not matching, and it is stuck in an image pull back off, okay. These others are okay. Remember the 3, okay. And I want you to take note of these things, okay, as we go through them. So the others are very okay, okay, except this one. This is what I'm talking about. It's stuck in an image. It has an issue, okay, trying to pull the image, okay. So it is saying an image pull back off. That's the status, meaning it tried to get the image and failed, so it backed off, okay. So there's a note for us here to read. They're saying note: the deployment controller stops the bad rollout automatically and stops scaling up the new replica set. Very good to know. Then they go on to tell us this depends on the rolling update parameters that you have specified, okay. So they're saying which parameter is that one? It's called the max available specifically. They're saying this depends on the rolling update parameters, max and available specifically that you have specified. Kubernetes by default sets the value to 25%. Okay, so it says that by default 25% is the maximum value for unavailability. Okay, so it's saying get the description of the deployment. Okay, kubectl describe deployment. By now we should know this command. Okay, by now I expect you to have been practicing. Okay, you should know the commands like kubectl get pods, kubectl get deployments, kubectl get services, kubectl describe pods, kubectl describe deployments. You should know like minikube start, okay, minikube stop, okay, maybe minikube destroy, okay, kubectl set image, kubectl edit deployment, okay, kubectl rollout status. All these are commands that should be now familiar to you. They're actually very easy, okay, very easy. If you practice, it becomes very easy. So yeah, this is the information we get. let's go. They say the output is similar to this. I don't know what they want us to get. They're saying checking rollout history of a deployment. Okay, they're saying to fix this, you need to roll back to a previous revision of a deployment that is stable. Okay, so let's first go to that description. Okay, to see any valuable data. Okay, first of all, at the bottom here, okay, you're talking about scaling up. Okay, they're saying scaling up replica set Nginx deployment from 0 to 1. Okay, let's go. So of course the user information. Okay, we get the name of the deployment, the namespace, the default namespace, the creation times tab, the label is app Nginx. Okay, annotations. Okay, is that okay? So you see the revision 5. Okay, the selector app because Nginx replicas. Okay, three are desired, one has been updated. There are 4 in total, 3 are available, 1 is unavailable. I hope this makes sense to you. Okay, given what we have been studying, if this alone does not make sense to you, I would request you go back and watch the past 4 videos. Okay, read and practice, don't only watch. Okay, read, practice. Okay, personally, I'm also going to create time to read the things again and practice them as many times as I need to. The strategy is rolling update, milliseconds ready 0, lowering up update strategy. The same, you see, this is what we got. Okay, that's by default it is 25% max unavailable, 25% max surge per template. Okay, then we have the labels, the container information, the host ports, the mounts, etc. Okay, so yeah, let's go on. Okay, because you see there's already an issue that there's 1 unavailable. Okay, so let's go on. So you're saying checking rollout history of a deployment. They're saying follow the steps given below to check the rollout history. They're saying first, check the revisions of this deployment. Okay, so you need the name of a deployment. So I'll copy the name of a deployment, but the command is kubectl rollout history. Okay, and I think it's a very simple command. Kubectl. Sometimes when a command is new, I would prefer to just type it out so that I get used to it. Kubectl. Okay, roll out like that. Then history. You need to spell history correctly. Then the name of the deployment. Like that. Okay. So they say the revision and then they change course. Okay. So we have 3, 4, 5. Okay. So you're saying the output is similar to this. Okay. Now they're explaining it. They're saying change cause is copied from the deployment annotation kubernetes.io change cause. Okay. Again, I read change cause is copied from the deployment annotation kubernetes.io/change cause to its revisions upon creation. Okay. So they're saying you can specify the change cause message by saying annotating the deployment with, okay, base command saying kubectl annotate, okay, then the deployment name, in our case is Nginx deployment, okay, then kubernetes.io change cause equals to image updated to this, okay. So that the thing that this change cause, okay, that you saw me having, I think like for example, change cause ours is none, okay, but they're saying it is something that is copied from a setting in kubernetes.io/change cause, and they saying it can be updated, okay. We can specify the change cause message by using annotate. Okay, so we're learning about a new command, a new subcommand to kubectl called annotate. Okay, so we annotate Nginx, we annotate a deployment. In our case, it's the Nginx deployment, and the change cause how we're updating it is by saying this change cause, okay, where the actual message is copied from is this value. Okay. This is the first way. Okay. The other one is saying by manually editing the manifest of the resource. Okay. Now they are saying to see the details of each revision. Okay. They're saying run kubectl rollout history, the deployment name. Then we pass a sub command specifying the revision number. Okay. So in my case here, there's no revision 2. Okay. But maybe I'll say revision. I'll choose revision 3. So I'll use the previous command. Okay. Then I say minus revision. Okay. Equals to 3. Hit enter. Okay. And we get the details. They say deployment.apps, Nginx deployment with revision 3. Okay. The pod template. Okay. They mention the labels. Okay. The pod template hash. If you remember this hash. Okay. The containers. Okay. It's an Nginx container, the image, the ports, the host port, the environment, if there's any mount, if there's any volume, if there's any node selector, tolerations. Okay. None. Okay, so that's how we see the details of each revision. If I clear this, okay, I can change to 4 to see the revisions of this revision 4. Okay, yeah, these things are very simple. I see nothing complex. Absolutely. Then they say the output is similar to this. Okay, and we've just seen this. Okay, now since we have seen the revision, okay, because to roll back you must move back to a revision. If there's no revision, you cannot roll back what is not there. So now we have a title here saying rolling back to a previous revision. Follow the steps given below to roll back the deployment from the current version to the previous version, which is version 2. Remember why we are rolling out. We are rolling out because we put a failing image. Okay? Don't forget that. We had a failing image. So we're going to do that. All right. So let's go back. They're saying now you have decided to undo the current rollout and roll back to the previous revision. So they're saying kubectl rollout undo deployment Nginx deployment. Okay. So yeah, simple command. Okay. Rollout. Remember, in fact, we have done this before, if you remember. Okay. We have the rollout status to see the status. Now here up we saw the rollout history, okay, to see the revisions, okay. Now we're moving back using undo, okay, to the simple command. So what is changing is just simply putting undo, okay. So if I paste that, okay, says that one has been rolled back. Then immediately I want to see the status, rollout status, okay, see, was successfully rolled out. And if I say kubectl get pods, you see, now all are running. We have successfully rolled out to the previous working state. So everything is okay. Okay. The failing state was gotten rid of. That failing image was not there. Okay. So saying alternatively, you can roll back to a specific revision. Okay. By specifying it with 2 revision. Okay. So you see they're saying kubectl rollout undo. Okay. The deployment name, then 2 revision. Okay, you didn't specify the revision. Okay, so I want to see the revisions available right now. Okay, so I'll say cube ctl just to show you in case you don't know the deployment to apply to. You can simply say kubectl get deployments. Okay, just reminding you. But by now, okay, so you see we have Nginx deployment. Then I'll say kubectl get, no, not get, but rollout. Okay, history. Okay, to see the current revision history. Then after that, I simply put that. okay? But I have to append, okay? Maybe I have to say deployment, okay? To be specific, deployment, then the actual deployment name. Then when I hit enter, you see, now we have 3, 5, 6, okay? I don't know if you remember what we had previously, but this is now what we have, 3, 5, 6, okay? So you see it's clearly a change. All right, time to continue. They're saying for more details about rollout related commands, read kubectl rollout. Okay, I won't go there. In case there's need, of course, we shall always check this documentation. They're saying the deployment is now rolled back to a previous stable revision. As you can see, a deployment rollback event for a rolling back to revision 2 is generated from deployment controller. Okay, they're saying check if the rollback was successful and the deployment is running as expected. Okay, and we checked. Okay, so this is actually a new way. Remember, the previous command I did was this. Okay, kubectl get deployment. Okay, but I didn't know that you can actually specify it like this. Okay, because actually this works if you want to see a specific deployment, that you say kubectl, okay, get deployment. Okay, this is now gone deployment. Okay, this makes sense actually. Then the deployment name. Okay, and we get a similar data. Okay, only that with get deployments, I'm sure if there was more than one deployment, I would have actually we'd actually see we'd actually see the, what is it called, the the different lists, okay, the different deployments. But now we have one. Okay, so we say give us all or show us only this one. It is the same because it's only one that is there. They're saying get the description of the deployment. So they're saying kubectl describe deployment nginx deployment. Okay, and yeah, of course we can do that. Okay, and this time you see 3 are desired, 3 have been updated, 3 total, 3 available, 0 unavailable. Okay, so yeah, happy days, it's all okay. Let's continue. So they're saying scaling a deployment. They're saying you can scale a deployment by using the following command. Okay, so say kubectl scale. Okay, then they mention the deployment name. Okay, then the number of replicas. Okay, and they're saying the output is similar to deployment.apps nginx deployment scaled. Okay, so remember we did this. Okay, I like that they're bringing it back. Okay, for us to revise and master and to understand it at even a deeper level. Okay, so this is actually a very good thing. Okay, and I'm going to do it in a moment. All right, so let's go ahead. I'll clear my screen. kubectl. So this is the deployment name. Okay, so to scale it, I can say kubectl. Okay, scale. The command is scale deployment slash. This is the deployment we want to scale, and we want the number of replicas. So replicas like that equals to 10. Isn't this nice? Okay, that using one command like this, we can easily scale our deployment. Okay, so I will hit it to, I'll hit enter. Okay, so deployment scale. And if I say kubectl rollout, okay, status deployment slash nginx deployment. Okay, See successfully rolled out. But I want you to see something also. If I say kubectl get pods, okay? How many pods do you think are there? You see, we have now a number of pods, okay? I think scale to 10. Seasons were recorded 27 seconds ago. Okay. Others 21 minutes. Updated, resetted it 21 minutes ago. Okay. So it's the meaning of scaling. This is nice. Okay. So they're saying let's read this. Assuming horizontal pod auto scaling is enabled in your cluster, you can set up an auto scaler for your deployment and choose the minimum and maximum number of pods you want to run based on CPU utilization of your existing pods. Doing code, long time, you've been lost. Welcome to today's stream. I hope you're doing well, and I hope you've learned enough of Kubernetes so far. Okay, so you're saying horizontal pod. What's horizontal pod scaling? Let me just open this link briefly to see what is here. Okay, so you're saying horizontal pod autoscaler, HPA for short, automatically updates a workload resource, such as a deployment or stateful state, with the aim of automatically scaling the workload to match demand. They're saying horizontal scaling means that the response is increased to that the response is increased. They're saying, let me read this again slowly. Horizontal scaling means that the response to increased load is to deploy more pods. Okay. Then they're saying this is different from vertical scaling, which for Kubernetes would mean assigning more resources. Okay, yeah. This makes sense now. I need just to check. So just to break it down for you. Doing code, it's been long since I heard from you. You've been quiet. Where have you been hiding? Okay. So, okay, of course, for horizontal scaling, in simple terms, would mean you increase the number of pods. Vertical scaling simply means you increase the resources on one pod. So in this case, it is horizontal scaling. So they're saying if it is enabled in our cluster, so they're saying we can set up an autoscaler for our deployment and choose the minimum and maximum number of pods we want to run based on CPU utilization of the existing pods. So let us see. So they're saying Kubernetes, yes, not Kubernetes, kubectl, autoscale deployment. Okay, so they're autoscaling a particular deployment. So order is not that when you're using kubectl, okay, maybe kubectl get, kubectl scale, kubectl describe, kubectl rollout. Okay, you always have to specify the deployment later. Okay. Doing code. Good morning to you. Says I know Kubernetes very well because of DevOps. I'm just here to say hi. Oh, that's good. There are many times when I would have actually used your help. Okay. Thank you for stopping by. Okay. Thank you for stopping by. Yeah. So this is me getting on my 15th day of learning Kubernetes, and hopefully I want to be like you. In a few, maybe in 1 month or two, because this is like I treat this like a learning experience for me. Then of course I'll apply to the flight booking engine, then yeah, keep on practicing. So this is October. So by end of December, I hope to be close, okay, to an average guy in Kubernetes with a lot of practice, okay? Like you'll see. Okay. Yeah, very, very happy that you know Kubernetes. What is one thing I should look out for? Okay, as someone who's experienced with Kubernetes, what is one thing I should look out for when learning Kubernetes? I'm very curious to know and to learn from your experience and wisdom. All right. So moving on, the saying, okay, kubectl, the name of the deployment, okay. The saying minimum Okay, so this is the minimum number of pods to run, okay, based on our CPU utilization of the existing pods. Then the maximum number of pods to run is 15, okay? And they're saying the CPU percentage, the CPU utilization should be 80%, okay? Okay. Doing code is asking me a question. He's saying, do you have any idea about Ansible? Yes, I have an idea about Ansible. Ansible is a configuration management tool, okay, used for managing things like uh, environment variables and settings for your application. Yeah, that's what I know about Ansible. And actually, in the flight booking application, I'm going to use Ansible. Yeah, I know about Ansible. I've used actually a similar tool, mostly called Puppet, okay, for similar role of or purpose of configuration management. Yeah. So yeah, very, very, very aware about Ansible. So yeah. So guys, let's continue. You see, this is how we set the minimum number of pods. So when the CPU utilization, okay, is 80% of the existing pods, okay, the minimum number of pods we should have are 10, okay, and the maximum number of pods should be 15. So at any point we should have 10 pods. In case we need more, okay, then go to 15. Okay. Doing code. Is there any other use case of Ansible that you have? You could let me know. So they're saying the output is similar to this. Okay, they're saying deployment.apps. Okay. Nginx deployment scaled. So I'll copy this. Okay. So clear paste. Okay. So you see that kubectl auto scale. Okay. This is now the new command we are learning. Okay. Today we have learned about the new command we have learned about is rollout history. Okay. To see the revisions, and then now auto scale. So auto scale, the deployment name. This is the minimum number of pods we need. Okay. The maximum number of pods. Then the percentage of the CPU utilization. So I'll hit enter. Aha, interesting. Says flag CPU percent has been deprecated. Okay. Use minus CPU with percentage or resource quantity format, e.g. 70% for utilization or 500 M for milli CPU. Okay. Then this is interesting. Okay, so but otherwise the thing has been auto scaled. Okay. Wow, sorry. Looks like this morning Flow is having a run at me. Okay, it has been deprecated to say using minus CPU with percentage or resource quantity format. Saying e.g. 7% for utilization or 500 M for milli CPU. Okay, so good to know that this has been deprecated. Looks like they need to update the documentation. Okay, so I want to check again for the number of pods. kubectl get pods. How many are these? 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, 10. Okay. This is a command we used to use that I use for counting the number of lines. I think this is it. Aha. Yeah, this is it. So we have 11 pods. Okay. If you don't know about Linux commands, again, I'm going to create a video about this. Okay. I know I've been promising about the Docker video, but trust me, I'm working on the Docker video. This video is going to have everything you need to know about Docker. Okay. So that you're comfortable working in projects which are Dockerized. It will make you understand. Let's say understand what containers are all about, when we're talking about them in Kubernetes. Okay, then even that I'll have to create a video about commands you need to know concerning what shell. Okay, shell scripting, so that I created like an order. Okay, I want to create like a roadmap so that someone will know that you first learn this, and I'll put them in a playlist so that someone knows you first learn A, then B, then C, then D, like that in that order, and it will help you. All right, so yeah, so this is simply prints the number of lines. Okay, if you don't know this, it's okay, but I'm simply counting the number of lines, okay, which have been output by this previous command. And this symbol simply says pass the output of this command as input to this command. Okay, clear. So we have one more topic here saying proportional scaling. Okay, they're saying rolling updates, rolling update deployments. Rolling update deployments support running multiple versions of an application at the same time. Okay, so they're saying when you or an autoscaler scales a rolling update deployment that is in the middle of a rollout, either in progress or paused, the deployment controller balances the additional replicas in the existing active replica sets, that is replica sets with pods, in order to mitigate risk. This is called proportional scaling. Okay, now I need to read this again. They're saying rolling update deployment support running multiple versions of an application at the same time. Okay, running multiple versions of an application at the same time. That's good. Now they're saying when you or an autoscaler scales a rolling update deployment that is in the middle of a rollout, okay, either in progress or pause, the deployment controller balances the additional replicas in the existing active replica sets, that is replica sets with pods, in order to mitigate risk. Okay, so this is interesting to know. Okay, so it has to balance. This is called proportional scaling. Okay, and they're saying, for example, you are running a deployment with 10 replicas, max surge equals to 3, and max unavailable equals to 2. Because to know max surge, you can simply open this. Okay, it has been appearing again and again and again. Okay, so you're saying max surge, they're saying it is an optional field that specifies the maximum number of pods that can be created over the desired number of pods. Okay, the maximum number of pods that can be created over the desired number of pods, that is max surge. Okay, then max unavailable. This should be obvious, but doesn't hurt to check. Okay, they're saying max unavailable is an optional field that specifies the maximum number of pods that can be unavailable during the update process. Okay, so this is the maximum number of pods that can be unavailable during the update process. And they're saying 2, and these are the maximum number of pods that can be, do you remember, that can be created over the desired number of pods. Okay, number of pods that can be created, number of pods that can be unavailable during an update. So they're saying ensure that the 10 replicas in your deployment are running. Of course, I did this. Okay, kubectl get deploy. Okay, this looks like a short command. We've only been using get deployments. Okay, this is the first time I'm seeing this word saying deploy. Let me see if there's a subtle difference with deployments. Okay, this is interesting. Okay, so get deploy and deployment, I think, gives you the same result. Like you see, we have the name, the ready, up to date, available, and age. They're all the same, have the same values. Okay, 10 out of 10. That 10 are desired, and 10 is the current state. 10 have been updated. Okay, until actually available. And it's been 24 hours since, okay, the first creation. So the same output is similar to this. They're saying, now they're saying you update to a new image, which happens to be unresolvable from inside the cluster, okay? So how do we update to a new image? There are two ways. Whether use the set image command, or we can edit the YAML file, okay? So they are doing this, okay? So I'll copy this, paste, okay? So say image updated, but of course this is, you see there's a mistake, okay? We have this sum tag thing, which should cause a failure. They're saying the image update starts a new rollout with the replica set nginx deployment that, okay? They're saying, but it's blocked due to the maximum unavailable requirement mentioned above. Check the rollout status. Maximum unavailable. Let us see what was it. Okay, let's continue. Okay, let me not take you so back. So we get the replica sets. And then you see that this one, okay, this one has 8 and has 0. This one has 5. Okay. So where did we set this? Okay. I can't remember where we did this. Okay. So let us read the explanation. They're saying then a new scaling request for the deployment comes along. The autoscaler increments the deployment replicas to 15. Okay. Then they're saying the deployment controller needs to decide where to add these new 5 replicas. Okay, I think I get it. It's because of this part. This. Okay, here. Okay, just to make them 15. Okay, initially, of course, we had 10. Okay, so the deployment controller needs to decide where to add these new 5 replicas. Okay, then they're saying if you weren't using proportional scaling, all 5 of them would be added in the new replica set. With proportional scaling, you spread the additional replicas across replica sets. Okay. Bigger proportions, they're saying bigger proportions go to the replica sets with the most replicas, and lower proportions go to replica sets with less replicas. So bigger proportions go to replica sets with the most replicas, and lower proportions go to replica sets with less replicas. Okay, so it is shared between replica sets. Okay, so they're saying any leftovers are added to the replica set with the most replicas. Replica sets with 0 replicas are not scaled up. Okay, now they are saying in our example above, 3 replicas are added to the old replica set, and 2 replicas are added to the new replica set. So they are shared because there are 5. Okay. Yeah, now I'm starting to get it. Okay. Because when I read something here, where was it? It was what? Yeah, this was beginning to what? To confuse me, but now I get it. Yeah. So they are shared. Okay. Because you have 5. Okay. you have 5. Remember, the 3 plus 2, you have 5 more to be created. But then 3, okay, are given to the old replica set because it has the most replicas. Then 2 are given to the new replica set because it has the lowest proportion. So they're saying the rollout process should eventually move all replicas to the new replica set. Assuming the new replicas become healthy. To confirm, they're saying we run this, okay? So they're saying the rollout process should eventually move all replicas to the new replica set. Okay, so they're just trying to explain the process. So let's clear this. Okay, so you see this, that 10 is what we need. 10 is desired, but 8 is what we have in the current state. So meaning 2 are missing, 5 have been updated, and 8 are available. Okay, so it's saying similar to this, but of course for ours it's different. Okay, unless if you missed out on a command. Did they type this? Did they do this? This auto scale thing? I hope I did. Yeah, I remember I did. All right, let's continue. So now you can confirm the status. Okay, I can clear this. Okay, and there we are. Yeah, this stuff is now starting to make sense. I know with more practice, it will get clearer. So pausing and resuming a rollout of a deployment. Wow, are we close? This stuff is long. Oh my God. It's too long. Okay. But let's try to get it done today. Okay, pausing and resuming a rollout of a deployment. All right, so they're saying when you update a deployment or plan to, you can pause rollouts for that deployment before you trigger one or more updates. When you are ready to apply those changes, you resume the rollouts. Okay, so you can want to update a deployment, pause a rollout before we trigger more updates. Okay, then they can be resumed. Okay, so by logic, anything that can be paused should be resumed. This approach allows you to apply multiple fixes in between pausing and resuming without triggering unnecessary rollouts. So saying, for example, with a deployment that was created, get the deployment details, okay? This should not be like second nature to us. That's the deployment we want. So the output is similar to this, okay? Get the rollout status, paste, that's the rollout status, okay? So the output is similar to this, okay? They're saying pause by running the following command, okay? So now rollout pause. On top of rollout history and rollout status, we're now getting pause. Okay, clear. Then I pause. This thing has been paused. Okay, interesting thing. Then update the image of then update the image of the deployment. Okay, this is nice. Set image to this. Okay, remember how to update the image of a deployment. So it has been updated. Okay, I like this. They're saying notice no new rollout started. So you can check the revisions by checking the rollout history. Okay, paste rollout history. You see, there's no new revision added. Then I think the output is similar to this. Deployments Nginx revision 1. Okay, but now we are past that. Okay, we are past that. Because we have had several of them. Okay. But yeah, none has been affected so far. That's the whole point. They're saying get the rollout status to verify that the existing replica set has not changed. Okay, let us find out. I'll clear, paste, and there we are. Okay, you see we're having the same stuff. Okay, then the output is similar to this. That's correct. And they're saying you can make as many updates as you wish. For example, update the resources that will be used. Okay, so like here you can say there's now a new command we are looking at, so going set resources. And what resource are they changing? Okay, I'm saying they're changing for Nginx. Okay, they're putting a CPU limit to this. Okay, and their memory, they're putting it to this. Interesting. Okay, let us update those resources. Okay, so it's saying resource requirements updated. Not so hard. So they're saying the initial state of the deployment prior to pausing its rollout will continue its function, but new updates to the deployment will not have any effect as long as the deployment rollout is paused. The initial state of the deployment prior to pausing its rollout will continue its function. Okay, yeah, everything else continues working, but the new updates will not have any effect as long as the deployment rollout is paused. Saying eventually resume the deployment rollout and observe a new replica set coming up with all the new updates. So with the command, we have rollout history, what I'm looking for, rollout pause. So after pausing, we can now resume. Okay. So we have seen this command. So kubectl rollout, what is changing now, we're using resume and the name of the deployment. So I'll copy this, clear my screen, paste, okay, resumed. Then the saying watch the status. Okay, can copy this. Okay, this is a new flag. So watching the status. Okay, saying kubectl get rs minus watch. So you see all these other ones have 0, 0, 0, 0, 0. This one has now 10. This new replica set has 10. Okay, and you see the seconds ago, it is 7 seconds ago. So up to date. So the output is similar to this. Okay. Okay, of course, ideally, if we're matching exactly what they have, would have that kind of output. Okay, but otherwise it's not. Ours happened and everything has been set up for us very very fast. Why? Because first of all, everything was already there. Okay, the pods were already there. We had about 10 pods. Okay, so when you change the image, okay, I think it just quickly picked up. Okay, so you see all we updated to this one replica set. But ideally, we're supposed to see something like this, okay? But yeah, I hope you get it. So say get the status of the latest rollout. Okay, so I can cancel this. Clear. I guess actually that watch command would have been done in another terminal, okay? So basically get the same thing here. You see, you cannot roll back a post deployment until you resume it. Okay, that makes sense. Deployment status. A deployment enters various states during its life cycle. It can be progressing while rolling out a new replica set. It can be complete or it can fail to progress. Progressing deployment. Kubernetes marks a deployment as progressing when one of the following tasks is performed. Okay, I want to read this again. A deployment enters various states during its life cycle. It can be progressing while rolling out a new replica set. Okay, it can be complete or it can fail to okay, yeah, so these are the states. Okay, the states. It's progressing to a new, it is finished, okay, complete, or it has failed. So the first state is progressing. It's saying Kubernetes marks a deployment as progressing when one of the following tasks is performed. Okay. Deployment creates a new replica set. Deployment is scaling up its newest replica set. Deployment is scaling down its older replica set. New pods become ready or available, ready for at least min ready seconds. Okay. Then they're saying when the rollout becomes progressing, the deployment controller adds a condition with the following attribute to the deployment status.conditions. Okay. Says type is progressing, status true, and then the reason that a new replica says new replica set created. Okay. Reason found new replica set. Reason replica set updated. So it can be one of these. Okay. That a new replica was created. Okay. Or one has been updated. Okay. So yeah, either when you're creating a new replica set, you're either scaling up or scaling down. Okay. Or when a new pod becomes available. Okay. Already. Says you can monitor the progress for a deployment by using kubectl rollout status. Yeah. We know that, guys. Don't we? We've done this command again. Okay. We can do the, we have known this. Okay. Come on. What's wrong with me? I can't even copy something correct. Like that. Okay. Says required resource not specified. Of course, it makes sense. We're supposed to specify the resource. Okay. Like the deployment. So yeah, you're talking about this. The deployment status says, but for now, this I think should actually be, can I say, is common sense the right word? That by default, of course, if we are things are happening, it will be in it will be either in progress, if it is successful and it has been completed, or it has failed to finish. Okay, so this is the first one they've told us about, and all these are things that we know about. Okay, now completing, they're saying Kubernetes marks a deployment as complete when it has the following characteristics. First one, all of the replicas associated with the deployment have been updated to the latest version you have specified, meaning any updates you have requested have been completed. It says or when all of the replicas associated with the deployment are available. Okay, so like when we update, okay, and then the any updates that we have been completed, that is complete, or when all the replicas associated with the deployment are available. They're saying when no old replicas for the deployment are running. Okay, so no old replicas should be running. Then they're saying when the rollout becomes complete, the deployment controller sets a condition with the following attributes to the deployment status.conditions. The type is progressing, status true, reason, new replica set, available. Okay, that makes sense. They're saying this progressing condition will retain a status of, they're saying this progressing condition will retain a status value of true until a new rollout is initiated. The condition holds even when availability of replicas changes, which does not affect the available condition. Okay, you can check if a deployment has completed by using kubectl rollout status. If the rollout completed successfully, kubectl rollout status returns a 0 exit code. Okay, so yeah, we have done this command again and again and again. At this point, it's just mastery. Okay, so to check that code, you can say echo $?. Okay, you see, this is how you get that exit code you're talking about. Okay, 0 means success. If it was a 1, it would be a failure. Say the output is similar to this. It's saying waiting for rollout to finish, 2.3 updated, blah blah blah. Yeah, this is something you'd expect. But in our case, everything has been very fast. Okay, so they're saying the exit status from kubectl rollout is 0, meaning success. And how do you find out? Using echo this. Okay, and I've just shown you that. Okay, looks like I saw the feature. Let's go. I like it when I do something and then it appears in the documentation. Okay, because actually, ideally, why would you talk about a zero exit code when someone doesn't know about it? Okay, maybe they are learning Kubernetes for the first time and they don't know about shell. All right, let's continue. Let me not over celebrate and talk about that. So, failed deployment. Your deployment may get stuck trying to deploy its newest replica set without ever completing. This can occur due to some of the following factors: insufficient quota, readiness probe failures, image pool errors, like we have been seeing, insufficient permissions, limit ranges, application runtime misconfiguration. Then they're saying one way you can detect this condition is to specify a deadline parameter in your deployment spec, which is .spec.progress deadline seconds. Then they're saying .spec.deadline seconds denotes the number of seconds the deployment controller waits before indicating in the deployment status that the deployment progress has stalled. Okay, so delaying trouble otherwise. Saying the following kubectl command sets the spec with progress deadlines. Okay, progress deadline seconds to make the controller report lack of progress of a rollout for a deployment after 10 minutes. Okay, so we're learning about a new command called patch, kubectl patch. Okay, they mention the name of the deployment, then they say -m. Okay, then they are updating the spec. Okay, that the spec. So you say this spec dot progress detail, progress deadline seconds. Okay, spec dot deadline seconds, and they're talking about 600. Okay, of this, which is the I think the 10 minutes they're talking about. Okay, I guess these are milliseconds, if I'm not certain. I need to think about this. Okay, so yeah, so when you see .spec progress deadline second, is simply think about it as a nested dictionary or a nested key value pair. Okay, you're seeing the output is similar to this. Okay, you can copy, and again, don't attempt to cram these commands. As soon as, the more we do them, the more we shall get used to them. They're saying the output is similar to this. Okay, now they're saying once the deadline has been exceeded, the deployment controller adds a deployment condition with the following attributes to the deployment's status conditions: type progressing, status false, reason progress deadline exceeded. Okay, now they're saying this condition can also fail early and is then set to status value of false due to reasons as ReplicaSet create error. Okay, and they're saying also the deadline is not taken into account anymore once the deployment rollout completes. See Kubernetes API conversions for more information on status conditions. Okay, let me read this again. The condition can also fail early and then is set to status value of false due to reasons as ReplicaSet create error. They're saying also the deadline is not taken into account anymore once the deployment rollout completes. Okay, note. Okay, Kubernetes takes no action on a stalled deployment other than to report a status condition with reason progress deadline exceeded. Higher level orchestrators can take advantage of it and act accordingly. For example, roll back the deployment to its previous version. Okay, so they're saying if you pause a deployment rollout, Kubernetes does not check progress against your specified deadline. You can safely pause a deployment rollout in the middle of a rollout and resume without triggering the condition for exceeding the deadline. So they're saying you may experience transient errors with your deployments, either due to a low timeout that you have set or due to any other kind of error that can be treated as transient. For example, let's suppose you have insufficient quota. If you describe the deployment, you will notice the following section. Okay, so yeah, we know about this. Okay, so yeah, this is what they want us to know: the conditions, available true, reason, minimum applicants available, progressing true, replica set updated, replica failure true, failed create. Okay, I'll not do that command again. We've done it over and over. Now they're saying if you run kubectl get deployment nginx -o YAML, the deployment status is similar to this. Okay, number of available replicas, then you see the conditions. Okay, see type progressing, reason, status. Okay, type available. Okay, message, type replica, replicas, observe generation, unavailable replicas. Maybe we can type this one. Yeah, so ideally, you see, we get the same stuff. Okay, we get the same stuff. If you look at the conditions, see the reason, the type, status, the message, the reason, status, type. Okay, ideally the same thing. So eventually, once the deployment progress deadline is exceeded, Kubernetes updates the status and the reason for progressing. Kubernetes updates eventually once the deployment progress deadline is exceeded, Kubernetes updates the status and the reason for the progressing condition. Okay, like so, available, progressing to those values, replica failure to also those values, like I've seen before. It's saying you can address an issue of insufficient quota by scaling down your deployment, by scaling down other controllers you may be running, or by increasing quota in your namespace. Good to know. Now they're saying if you satisfy the quota conditions and the deployment controller, then if you satisfy the quota conditions and the deployment controller then completes the deployment rollout, you will see the deployment status update with the successful condition status true and reason new replica set available. Okay, so from here you see replica failure, failed to create, and here you have new replica set available because they're trying now to explain the changes. Okay, so you're saying type available with status true means that your deployment has minimum availability. Minimum availability is detected by the parameters specified in the deployment strategy. Type progressing with status true means your deployment is either in the middle of a rollout and is progressing, or it has successfully completed its progress and the minimum required new replicas are available. See the reason of condition for particulars in our case. Reason new replica set available means that the deployment is complete. Okay, yeah, this is just now going on a deeper level, okay, to understand a few things. Okay, so just to make sure I've understood this, okay. So available, type available status true means minimum availability. Okay, type progressing status true means deployment is in the middle of a rollout. Okay, so in this case, okay, type, we have a type of progressing. Okay, status true. Okay, we're not showing the status here, but ideally you're saying in our case the reason is new replica set available means the deployment is complete, so it's not progressing. Okay, so progressing with type since it means it's the middle of a rollout or progressing successfully, or it has successfully completed. You can check if a deployment has failed to progress using kubectl rollout status. Now we know this. kubectl rollout status returns a non-exit code if the deployment has exceeded the progression deadline. Okay, we know about this command. I'll not run it. Saying the output is similar to this. Okay, we know this. And the exit code, they're saying the exit status from kubectl is 1, indicating an error. Okay, I've also explained what all this means. Okay, so when you run this, you'll either get a 1 or a 0. So this command simply means that the previous command failed or succeeded. Okay, so when you get a 1, it means things are bad. Something bad happened to the previous command. In our case, the previous command would be this, okay? All right, so operating on a failed deployment. All actions that apply to a complete deployment also apply to a failed deployment. You can scale it up or down, roll back to a previous version, or even pause it if you need to apply multiple tweaks in a deployment pod template. Okay, so you can scale it up or down, roll it back to previous version, or even pause if you need to apply multiple tweaks in the deployment pod template. Then we have the cleanup policy. They're saying you can set a .spec.revision history limit field in a deployment to specify how many old replicas for this deployment you want to retain. The rest will be garbage collected in the background. By default, it is 10. 10, I think, is good enough. Note, explicitly setting this field to 0 will result in cleaning up all the history of your deployment. Thus, that deployment will not be able to roll back. Risky. I don't know why anyone would do that. The cleanup only starts after the deployment reaches a complete state. If you set the spec.revision history limit to 0, only, and I mean any rollout nonetheless triggers creation of a new replica set before Kubernetes removes the old one. Okay. So yeah, a new one will be created. I mean a new replica set will be triggered either way. They're saying even with a non-zero revision history limit, you have more replica sets than the limit you configure. Then they're explaining that, for example, if pods are crash looping and there are multiple rollouts and there are multiple rolling updates. For example, if pods are crash looping and there are multiple rolling updates events triggered over time, you might end up with more replica sets than the expected revision history limit because the deployment never reaches a complete state. Okay, yeah, because now there's something new being created. You just wait for maybe a new one to be like there has to be like a number of pods have to be enough, okay, before an old one is what like deleted. The new pods have to be actually really functioning before an old one is removed. That makes sense. Canary deployment. They're saying if you want to roll out releases to a subset of users or servers using the deployment, you can create multiple deployments, one for each release, following the canary pattern described in managing resources. Okay, this is something that we can learn about later, not now. Writing a deployment spec. The thing, as with all other Kubernetes configs, deployment needs a .api version, a .kind, and metadata fields. For general information about working with config files, see deploying applications, configuring containers, and using kubectl to manage resources. Okay, I'll open that because we won't look at it right now. So they're saying when the control plane creates new pods for deployment, the metadata.name of the deployment is part of the basis for naming those pods. The name of a deployment must be a valid DNS subdomain value, but this can produce unexpected results for the pod host names. For best compatibility, the name should follow the more restrictive rules for a DNS label. A deployment also needs a .spec section. Okay, so they're now simply going through the sections, okay, of when you write what to do when you're writing a deployment spec. Okay, that's how I understand it. That the spec simply needs an API version, a kind, and metadata. So yeah, I think they're trying to say that we can write our own. Okay. So the pod template is saying the pod template. Ideally, I think what you need is simply to understand what is going on. Okay, what they mean. If I see this, okay, running this, No, this is something we shall see later. Let me remove this. So the pod template is saying spec the template and spec the selector are the only required fields of the spec. They're saying spec the template is a pod template. It has exactly the same schema as a pod, except it is nested and does not have an API version or kind. Okay, so you're saying in addition to required fields for a pod template in a deployment must specify appropriate labels and appropriate restart policy for labels. Make sure not overlap with other controllers. See selector. They're saying only a spec template spec restart policy equal to always is allowed, which is the default if not specified. Then you have replicas. They're saying replicas is an optional field that specifies the number of desired pods, defaults to 1. They're saying you should manually scale a deployment example via kubectl scale deployment. So they're not saying let me read this again. Should you manually scale a deployment example via kubectl scale deployment that, okay? Then they're saying then you need to update the deployment based on a manifest, for example, by running kubectl apply -f that. They're saying then applying that manifest overrides the manual scaling that you previously did. Okay, so applying the manifest, okay, overrides this. Okay, I think for me I would prefer applying to the manifest so that anyone who gets the specification can have the same behavior. They're saying if a horizontal pod autoscaler or any similar API for horizontal scaling is managing scaling for deployment, .set .spec replicas. If a horizontal pod scaler or any similar API for horizontal scaling is managing scaling for deployment, .set .spec. Okay, that makes sense. In other words, if something else is handling our scaling, then we don't need that. So it's saying instead allow Kubernetes control plane to manage the .spec replicas automatically. Okay, so that is if you're using an auto scaler. Okay, then you have the selector. So the selector is a required field that specifies a label for the pods targeted by this deployment. Saying the selector must match spec template metadata.labels or it will be rejected by the API. Then you're saying in API version apps v1 spec selector metadata.labels do not default to spec template.metadata.labels if not set. So they must be set explicitly. Also note that spec.selector is immutable after creation of the deployment in apps v1. Yeah, we saw this in a past study. Then they're saying a deployment may terminate pods whose labels match the selector if their template is different from spec template or if the number of if the total number of such pods exceeds spec replicas. It brings up new pods with .spec template if the number of pods is less than the desired number. Wow, there's a lot to read. Okay, and yeah, my mind is now like literally tired. Okay, there's a lot to read. Oh my god. So this is what I'm going to suggest. Okay, I want us to do an example. So what all this is doing is this. Okay, clear vim. Okay, they're explaining these parts. Okay, each of these is being explained now in detail. Okay, what they are and what they do. Okay, they're explaining the pod template. They explain the replicas. Okay, this is spec that replicas. Okay, being explained. That if you want an autoscaler, don't have this. Okay, they also go on to explain spec.selector. Okay, which is this one here, spec.selector. Okay, which is specifies a label for the pods targeted by the deployment. Okay, then what else do they have? They explain strategy. Do we have strategy here? We don't. They're saying speculative strategy specifies the strategy used to replace old pods by new pods. Okay. So they're saying the type can be recreate or rolling update. So they're saying rolling update is the default value. Then you have the recreate deployment, saying all existing pods are killed before new ones are created when speculative type equals to recreate. Okay. So all are killed before the new ones are created. Okay. This is yeah, tough. Okay. I would prefer a rolling update, that the old ones are only killed when the new ones are available and okay and healthy. Then they're saying this will only guarantee pod termination. This will only guarantee pod termination previous to creation for upgrades. If you upgrade a deployment, all pods of the old revision will be terminated immediately. Successful removal is awaited before any pod of the new revision is created. If you manually delete a pod, okay, if you manually delete a pod, the lifecycle is controlled by the replica set and the replacement will be created immediately, even if the old pod is still in terminated state. If you manually delete a pod, the lifecycle is controlled by the replica set and the replacement will be created immediately, even if the old pod is still in a terminating state. And they're saying if you need an utmost guarantee for your pods, you should consider using stateful state. I guess that is something to learn about, okay, later. So they have here stateful state saying a stateful state runs a group of pods and maintains a sticky identity for each of those pods. This is useful for managing applications that need persistent storage or a stable, unique network identity. Okay, can leave that for now. Then we go to the rolling update deployment. Okay, so you're now going into detail of some of these settings. Okay, like max and available. Okay, we have studied this, if you remember. Max surge, we have studied this. Okay, of course here we don't have them, but we're able to change them using kubectl command. Okay, they go into commands. Okay, so I want to show you in here. It's not there. Then they have the progress deadline seconds that they mentioned. They have the mean ready seconds that they mentioned about. Okay, so my suggestion is that I'm running out of time. Okay, my suggestion is that you read. Okay, take time to read this. I'm also going to take time to read this. Well, where have we read? We read up to the strategy, up to recreate. Okay, but actually, if you think about it, we studied, they highlighted all this above. Okay, above there where we're reading. So yeah, simply maximum available, but simply, like yes, they're saying it's simply the maximum number of pods that can be available during the update process. Okay, then they explain using an example saying when the value is set to 30%, the old replica set can be scaled down to 7% of desired pods immediately when the rolling update starts. Then you have the max surge, which is the maximum number of pods that can be created over the desired pods. Okay, as simple as that. Then they give an example. You can read that. Okay, then they have examples. Okay, for max available. Okay, then they have, I think, strategy type, loading update, then max available. Okay, when you go to max surge, when you go down, you see the strategy is type rolling update, max surge 1. Then hybrid, okay, you see you have a max surge and max available. Okay, so take time to read this. Then when you go down, you have the progress deadline seconds, the mini read seconds. Okay, then of course they now, I think, explain the revision limit in detail, paused in detail. Okay, yeah, so looks like it's not even that much. Okay, maybe let's actually read. Okay, let's read and get done with this. Let me see the time. I don't want to be late for the next activities. Okay, let me try to go through this. So rolling update is saying the deployment updates pods in a rolling update fashion, gradually scale down the old replica sets and scale up the new one. When spec.type equals rolling update, you can specify the maximum available and max surge to control the rolling update process. So saying spec.strategy.rolling update max available is an optional field that specifies the maximum number of pods that can be available during the update. The value can be an absolute number, for example, 5, or a percentage of desired pods, for example, 10%. The absolute number is calculated from percentage by rounding down. The value cannot be 0 if spec.strategy.rolling update.max surge is 0. The default value is 25%. For example, when this value is 30%, the old replica set can be scaled down to 70% of desired pods immediately when the rolling update starts. Once pods are ready, okay, the old replica set can be scaled down further, followed by scaling up the new replica set, ensuring that the total number of pods available at all times during the update is at least 70% of the desired pods. Yeah. So maximum number of pods that can be unavailable. Okay. So if we say that we want 30%, at least 30%, only 30% can be unavailable during an update. That means 70% must always be, okay? I'm trying to understand this. So 30% can be unavailable. So the old request can be, okay, yeah, I now get it. Okay. So max surge, okay, is saying an optional field that specifies the maximum number of pods that can be created over the desired number of pods, okay? In a similar way, it can be an absolute number, like, for example, 5, or a percentage of desired pods, for example, 10%. The value cannot be 0 if maximum available is 0. The absolute number is calculated from the percentage by rounding up. Default value is 25%. Then you're saying, for example, when the value is 30%, the new replica set can be scaled up immediately when the rolling update starts, such that the total number of old and new pods does not exceed 130% of the desired pods. Once all pods have been killed, the new replica set can be scaled up further, ensuring that the total number of pods running at any time during the update is at most 130% of desired pods. Here are some rolling update deployment examples that uses the max available and max surge. Okay, and we have seen this. Okay, strategy type. Okay, this is a hybrid having both. So if you only want max surge, you remove this. If you want only max available, you remove this. Just like if I come here, okay, you see only max surge in the strategy. If I come to max available, you see only max available. Okay, so you tailor it according to your needs. Then you have the progress deadline seconds. They're saying this one is an optional field that specifies the number of seconds you want to wait for your deployment to progress before the system reports back that the deployment has failed progressing. Surfaced as a condition with type progressing, status false, reason progress deadline exceeded in the status of the resource. They're saying the deployment controller will keep retrying the deployment. This defaults to 600. In the future, once an automatic rollback will be implemented, the deployment controller will roll back a deployment as soon as it observes such a condition. If specified, this field needs to be greater than spec.min ready seconds. What is min ready seconds is here. Okay, they're saying spec.min ready seconds is an optional field that specifies the minimum number of seconds for which a newly created pod should be ready without any of its containers crashing for it to be considered available. This defaults to 0. The pod will be considered available as soon as it is ready. To learn more about when a pod is considered ready, see container probes. Okay, we'll not go into that. And they're saying terminating pods. It's saying feature state. Kubernetes version v.33 alpha enabled by default false. Okay. And they're saying you enable this feature by setting the deployment replica set terminating replicas feature get on the API server and on the kube control manager. They're saying pods that become terminating due to deletion or scale down may take a long time to terminate and may consume additional resources during that period. As a result, the total number of all pods can temporarily exceed spec.replicas. Terminating pods can be tracked using the status, the terminating replicas field of the deployment. Then we have the revision history limit. So guys, all this is simply explaining the contents of this file. Okay, what goes here. Okay, so like you see here, what is not here is the what can I call it? The default values. Okay, default values are not default values, which are the optional values which have default values are not in the spec. Okay, but I'm simply trying to explain what you can put in the spec. Okay, but it's important that you understand this. Okay, I would suggest that you can actually tell AI to generate for you the kind of spec you want. Then you can tweak it. Okay, you tweak. You understand? You tweak it to make changes. Because to tweak it, you must understand what you're changing. Okay, so you don't have to master all this. Even me personally, I wouldn't. I don't think I might be able to explain everything in the in this, but most of them, of course, I understand them. Okay, and from time to time, I'll be coming to this documentation. Okay, to check as we continue building. Okay, had I read this? Okay, I don't think I had read this. So a deployment's revision history is stored in the replica set it controls. In the replica sets it controls. .spec.revision history limit is an optional field that specifies the number of old replica sets to retain to roll back. These old replica sets consume resources in etcd and crowd the output of kubectl rs. The configuration of each deployment revision is stored in its replica sets. Therefore, once an old replica set is deleted, you lose the ability to roll back to that revision of deployment. By default, 10 old replica sets will be kept. However, its ideal value depends on the frequency and stability of new deployments. More specifically, setting this field to 0 means that old replica sets with 0 replicas will be cleaned up. In this case, a new deployment rollout cannot be undone. I want to read this again. More specifically, setting this field to 0 means that all replica sets with 0 replicas will be cleaned up. In this case, a new deployment rollout cannot be undone. Setting its revision history. Since its revision in this case, a new deployment rollout cannot be undone since its revision history is cleaned up. Makes sense? Paused. Okay. They're saying spec.pause is an optional Boolean field for pausing and resuming a deployment. The only difference between a paused deployment and one that is not paused is that any changes in the pod template spec of the pod deployment will not trigger new rollouts as long as it is paused. A deployment is not paused by default when it is created. Saying the only difference between a paused deployment and one that is not paused is that any changes in the pod template spec of the paused deployment will not trigger new rollouts as long as it is paused. Okay, makes sense. A deployment is not paused by default when it is created. So you have to explicitly pause it. Okay. So we're not going to look at pods next. Okay. But we're going now to apply this to real applications. Okay. So tomorrow let's look at a real good example, okay, to help us gather everything we have studied, okay. And from time to time, I really encourage you to check it, read the documentation, okay. The more number of times you read, the more you understand, okay. So here they simply explain to us how to write, okay, a deployment spec. Where's that title? I might have missed it, okay. Writing a deployment spec, okay. And I can suggest you to use AI to write for you the deployment spec, okay. But if you need a particular field, okay, you can tell AI to add that field for you, okay. And if you forget what a field means, simply come here, okay. Read about these fields, okay, and what they mean. Personally, I'm going to be checking this from time to time. So see you in the next stream. Bye for now.